This lesson is about exact values. So let's jump down to the interactive panel. We'll go across to exact values. Press play. There are some special angles that we want to be able to do without a calculator. They're special because they're very common and important in lots of areas of maths. The first is 60 degrees. So we're going to have this table here that we're going to fill in. The first one of those angles is 60 degrees. We're going to fill in this table as we go, showing the results of sine theta, cos theta, and tan theta of these special angles. One of the main places that 60 degrees appears is in equilateral triangles. And if we were to cut it in half down the middle, then this 60 degrees would be cut in half. And theta would be half of 60, which is 30 degrees, which is another one of our special angles. Nice. Next. Another very common shape is the square. Which angle goes in each corner of a square? That would be 90 degrees. And if we bisect a square diagonally, we make two triangles. Yep, so one here and one here. And these 90-degree angles would also be cut in half. And each of these new angles would be half of 90 degrees, which is 45 degrees, which is another special angle. Okay. Now, one important thing we need to keep in mind about sine theta, cos theta, and tan theta is that because they're based on the angles in the right-angled triangles, they're ratios, meaning that as long as the angles stay the same, the values of sine theta, cos theta, and tan theta will stay the same, even if it's a different size triangle to what we've been using in the unit circle. For example, if we make a copy of this triangle, but make it twice as big, the angles would all stay the same, but now all the lengths are twice as long. Okay. Let's calculate sine theta for the left triangle. Replace theta, O, and H in the formula with the lengths of the opposite and the hypotenuse. Okay, so for the left triangle, theta is 30 degrees. So let's do that. And then O is, the opposite side is 5. And the hypotenuse is 10. Now replace 5 over 10 with the result of 5 divided by 10 as a decimal, not a fraction. So that would be 0.5. Nice. Now let's make sure that also works for the bigger 30-degree triangle. Replace theta, O, and H in the formula with the lengths of the opposite and the hypotenuse for the second triangle. Okay, so for the second triangle, 30 degrees is the angle, and then the opposite is 10 now, and the hypotenuse is 20. Now replace 10 over 20 with the result of 10 divided by 20 as a decimal, and that would be 10 divided by 10 divided by 20 is 0.5. Awesome. So as you can see, as long as the angles stay the same, the side lengths will have the same ratio. As the hypotenuse gets longer, the other sides also get longer, and in this 30-degree triangle, the opposite is always half the length of the hypotenuse, which is why sine 30 always equals 0.5. Okay. With that in mind, for this section we're going to use hypotenuses with different lengths than 1. Because, as you're about to see, to fill in our special angles table, the numbers will work better when the hypotenuse isn't 1. Trace out our regular unit circle first. Okay, let's click and drag it around. Now let's trace another circle using a line with a length of 2 instead. Okay, so same thing. Let's create an equilateral triangle. Find this angle. Okay, so it goes up a fair way. Let's say maybe like 50. And then maybe like 55. 60. Oh, cool. Now drag the button to make a path to the next food. Okay, like that. Now drag the button to make a path back to the center. Okay, this way. Okay, cool. Now let's cut the triangle in half to turn it into a right angle triangle so we can use sine, cos and tan. Alright. Type in how far the frog has to jump to the right to reach this food. This one right here. Okay, well, it's to the edge of the first circle, so it should just be 1. Cool. Nice. Now drag the button straight up to bisect the triangle, so to cut it in half. Alright. Like that. Frog's got a lot of jumping to do this lesson. Good job. Now that 60 degrees got split in half and turned into 2 angles of, okay, so here, half of 60 is 30. Awesome. We won't need the second half of the equilateral triangle anymore, so we'll get rid of that. Now we need to find the length of the opposite side. A clean way to do this is actually to use the Pythagoras theorem. Remember, C is the length of the hypotenuse, and A and B are the lengths of the other two sides. Replace C with the length of the hypotenuse and A with the length of the adjacent. Don't simplify yet, so for example, don't turn 6 squared into 36. So literally just the length of the hypotenuse here, it goes from the center out to the edge of the circle, and that circle has a radius of 2. So from here to here is 2, and then also from here to here is 2. So we can replace C with 2. And using the arrow keys is going to be really helpful in this one to navigate the different parts of the equation. And then the adjacent is down here, so that should just be 1. Cool. Nice, now simplify just the powers without rearranging yet. So replace 2 squared and 1 squared with what they actually equal. So 2 squared is 4. And 1 squared is just 1. Cool. Now, if we minus 1 from both sides, what are we left with on each side? Okay, if we minus 1 from the right-hand side, then we'll have 1 minus 1, which is 0, and we'll just get left with the b squared. If we minus 1 from 4, we'll get left with 3. And so we're getting closer to working out what this b is, basically, by subtracting the 1 from both sides to cancel out that 1. Perfect. Finally, let's square root both sides to cancel out the squared on the b. You can type in square to square root, and don't actually solve for the square root of 3, just leave it as square root of 3 for now. Okay, so on the right-hand side, if we square root that, then it'll be square root of b squared, which is just b. So that'll just cancel that out. On the right-hand side, if we square root, we'll just get left with square root of 3. And so there. Now it's hard to type it and like get the existing 3 under the square root, so just literally type square root of 3 and then just backspace that one. That's the easiest way to handle square roots. Okay, that's that. Great job. So this opposite side is just square root of 3. We're not going to use a calculator to solve the square root of 3 because remember how we kept getting rounding errors in the earlier levels? If we leave it as square root of 3 and only round at the very end or when we absolutely need to, we can avoid the rounding errors. Also, once you get used to it, it makes your working and answers much neater and easier to use. Okay, now let's start filling in our table. We'll start with 60 degrees because we have 60-degree angle in the center of the circle where we're used to it. So we won't do the 30 degrees yet. We'll start with the 60, which is in the familiar place. Type in the formula for sine theta from SOHCAHTOA. Check the hints if you forgot the formula, but type in your best attempt first. Okay, so sine theta equals, and then SOHCAHTOA, so it's O over H. Nice. Replace theta, O, and H in the formula with the 60-degree angle and lengths of the opposite and hypotenuse. Right, well the theta is just going to be 60, and the opposite the 60 is root 3. So replace O with SQRT 3. The hypotenuse we said was 2 because it's the same as the radius of the circle, and the radius of the circle is 2. So we'll do that. Nice, and again we won't solve the square root and fraction because it would equal 0.866 and we'd have to round it. But leaving it as this fraction is actually pretty simple and neat, and we won't have any rounding errors. Type the result we just found for sine 60 into its spot in the table and press enter. Okay, so square root of 3 and then over 2. So this is an easy mistake to make, doing the over too early, because see how now the entire 3 over 2 is inside the square root. So let's backspace that part. We need to type the square root of 3 and then use the right arrow key to get out of the square root, and now we can go over 2. So in total it'd be SQRT 3 and then press the right arrow key, and now you can see it's not highlighting. Right now it's highlighting because it's still inside the square root, but if we press the right arrow key it will be outside of it, and then we can over 2 and then press enter. Awesome. Let's do cos 60 now. Type in the formula for cos theta, or check the hint if you need a reminder. So cos theta, and then SOHCAH, which is A over H. Nice. Replace theta, A, and H in the formula with the 60-degree angle and lengths of the adjacent and hypotenuse. So theta is 60. Adjacent is down here, which is 1. Okay, and the hypotenuse is 2, just like before. Nice. Now solving this fraction leaves us with 0.5, which is simple and wouldn't cause a rounding error, but we're still going to keep it as a fraction so that it fits in with the other values in the table, as you'll see in the next steps. So see how this one's over 2? There's going to be other ones that are over 2 as well, and so it is easy just to leave this fraction as something over 2 as well. Go ahead and add our result to the table in the cos 60 spot. Okay, well that's just 1 over 2. Easy. Nice. Finally, let's do tan 60. Type in the formula for tan theta first, check the hint if you need. Tan theta equals, and then SOHCAHTOA, so O over A. Nice. Now replace the variables theta, O, and A. So theta is still 60. Opposite is square root of 3. And the adjacent is this one down here, so just 1. Good job. Now just simplify the fraction. Don't solve the square root of 3, just simplify the fraction. Alright. Well, square root of 3 divided by 1. If you divide by 1, nothing happens, so we can just get rid of that. Okay. Nice, now add to the table. Square root of 3, done. Nice, let's do the 30-degree ones now. We can use the same triangle, seeing as it has a 60-degree angle and a 30-degree, but we'll need to change our opposite and adjacent side, seeing as we're changing which angle in the triangle we're using. Okay, so now using the 30 instead of the 60, the opposite is down here, and the adjacent is over here. But the hypotenuse will stay the same because it's still opposite the right angle. Yeah, okay, so the hypotenuse is still there because the right angle is still here. So using the 30 degrees, let's work out sine theta so we can add it to the table. Type in the sine theta formula. Okay. Replace theta, O, and H in the formula. So theta is now 30. The opposite is down here, which is 1. Oops. And the adjacent is now this square root of 3 here. So like that. Oh, what did I do wrong? What did I do wrong? Hang on. Okay, this is a great time to use the reset button here. So before I started messing with it, what do we have? Oh, I put the adjacent on the bottom instead of, I should have had the hypotenuse. My bad. So sine 30, opposite is 1, hypotenuse is 2. There we go. Type the result we just found into its spot in the table and press enter. Okay, 1 over 2. Oh, what the heck did I just type? 1/2. There we go. Awesome. Let's do cos theta now. Type in the formula. Cos theta equals adjacent over hypotenuse. Nice. Now replace theta, a, and h in the formula with the angle and lengths of the adjacent and hypotenuse. Okay, so theta is 30. Adjacent is square root of 3. And the hypotenuse is 2. Cool. Add it to the table. Square root of 3. And again, if we type the over straight away, it's going to be inside the square root still. So make sure we go to the right and go over 2. Awesome. Did you notice that we got the same results as sine 60 and cos 60, but they're just swapped around? Okay, so we got 1/2 down here for cos 60, and then sine 30 got us 1/2. And then over here, we got root 3 on 2 for 60, for sine 60, and then cos 30 got square root of 3/2 as well. Huh. It's not a coincidence. This always happens with sine and cos. If it's a right angle triangle and we just swap from one angle to the other like we just did, then the opposite and adjacent sides swap. Yeah, I mean, that's what we did, right? Originally the adjacent was down here, opposite was over here when we're using the 60, but now they swapped. So the results of sine and cos will also swap. Okay. Lastly, let's do tan 30. Type in the formula for tan theta. Tan theta equals O over A. Nice. Now replace the variables theta, O, and A. Okay, so theta is 30. The opposite is 1. And the adjacent is square root of 3. Awesome. You might have noticed this one is also like tan 60, just flipped. So yeah, tan 60 was root 3. Yeah, and that's because similar to sine and cos, the result gets swapped because the adjacent opposite sides were swapped when we changed the other angle. Okay, that makes sense. This time the 1 won't cancel out because it's not because it's on the top, not the bottom of the fraction, which is quite different. Let's add it to the table. So yeah, just to quickly explain a bit more as well. Over here we got square root of 3 on 1, and then the 1 ended up cancelling out because it doesn't do anything. And then over here we got 1 over square root of 3. And this time the 1 won't cancel out because that 1 is actually doing something, whereas this one over here wasn't. Okay, press enter. Perfect. We've done both the angles in this triangle now, so we need to move on to the other special one. Like we saw earlier, a common place it appears is in a square. Drag the button to the right to start the square. Okay, drag the button over here. Now drag it straight up. And to the left. And back down. Type in the angle to rotate the log to this food. Okay, so if I go up here, it looks like it's kind of like halfway. So that'd be 45. Nice. Now, as you can see, our log, the hypotenuse, needs to be longer to reach the food. Yeah, we can't quite go up there at the moment. Let's work out how long it needs to be. So how much do we need to go to get to there? Because this line will create 2 right angle triangles, we can use Pythagoras theorem again. So this line and the log being here is cutting it in half, and we have 1 right angle triangle here and 1 right angle triangle up here. Replace the variables with the values we know. Right, so this would be the hypotenuse, but we don't know what the hypotenuse is, that's what we're trying to find. Okay, so what about the other 2 sides? Well, we have, this one is just going to be 1, so we can change that. And then what about B, the other side? That'll be up here. What's that one going to be? Well, from here to here lines up with from here to here. And from here to here is from the center to the edge of the circle. So that's the radius. and the radius of this circle is 1, just like down here, and it's the unit circle, so it's going to be 1. So that means this from here to here should be the same as that, so that should just be 1 as well. Now work out the 1 squareds, don't add them together yet. Okay, so it just means what is 1 squared? It's just 1. And what is 1 squared? It's just 1. So, and now we can add the 1s. 1 plus 1 is 2. And lastly, to solve for c, square root both sides and type in the result. Okay, so to get rid of the squared on the c, we're going to square root it, which would get rid of the squared. And then over here, we're going to square root this as well. And we can't get the 2 inside, so we'll just write a new 2 there, and we'll get rid of that 2. Awesome. So our log, hypotenuse, needs to be square root of 2 long. Okay, so we're extending it to there. The whole thing's root 2 now, which is about 1.41, but let's keep it as square root of 2 so we don't have rounding errors. Okay, so square root of 2 is 1.41-ish. That's rounded. So it makes sense that we go from here to here, which would be 1, and then we go a bit extra. Okay, nice. Now let's work out sine, cos, and tan for this 45-degree angle. Type in the formula for sine theta. So sine theta equals opposite over hypotenuse. Replace the things. So our theta now is 45 degrees. Our opposite 45 degrees is this one, which we said was 1. And then the hypotenuse is this guy here, and that is square root of 2. That's great. Now, we should clean up our answer a bit by rationalizing the denominator. If you're a bit rusty on how to do that, don't worry, I'll walk you through it now. And don't spend too much time trying to understand it perfectly for now. We're only going to use it a few times to clean up a few answers, then we won't use it again on this topic. So, the square root on the bottom is considered to be kind of messy, so let's cancel it out. I'll mention real quick now, earlier we do have a square root on the bottom, which is just here, and we chose to just, that one was fine, so why is this one not fine? This one over here isn't fine. Ideally, we should rationalize this one too, but as you'll see, there's a method to memorize this table, and it's handy for the memorization if this square root of 3 is on the bottom for this one, and so for the table, we're going to leave it on the bottom. But you technically should rationalize it when you actually use it as part of an answer. But a lot of times this won't be your final answer anyway, and so it's fine to have it in the table with the square root on the bottom. This one having the square root on the bottom is kind of also fine as well, but as you'll see, by rationalizing the denominator here and not having a square root on the bottom, it makes it easier to memorize with the system we're going to use. Basically, you're going to end up with a 2 on the bottom instead of a square root of 2, and you might have noticed all these fractions have a 2 on the bottom as well. So we shouldn't have square roots on the bottom ideally of a fraction, but it's not a massive deal, and so we're going to leave this one. We're definitely going to fix it on this one because it makes it easier to memorize because it blends in with the other ones. All right, let's actually do it now. We need to times the bottom by square root of 2 because square root of 2 times square root of 2 just equals 2, okay? So change the bottom of the fraction to square root of 2 times square root of 2. Press shift and then 8 to make the times symbol. Okay, and if you ever forget that, you can see it here as well. The times symbol is the asterisk on your keyboard, and you can get the asterisk by holding down shift and pressing 8. Okay, now this is a little bit weird in here. I think the cursor is still in the square root there. So if we press the right arrow key, we should be out of that now. But the fraction's still highlighted because we're still in the fraction. If we went to the right, now we're out of the fraction. Going to the left, where we're just on the edge of the fraction there. So we can go shift 8 to make the times, and then type square root of 2. If that formatting is a bit hard to do, sometimes this input window, it's pretty good, but sometimes it can be hard to type the exact thing you want. So give it your best shot and use the arrow keys and think about where the cursor is. But you can also just press the skip button if it's too hard to actually type what you want to type. So to show you what happens, press skip and it'll put the answer in. And yeah. Nice. Now we can't just randomly times the denominator by something. So we also have to times the top by square root of 2. Change the top of the fraction, the numerator, to 1 times square root of 2. Okay, so we're not allowed to just randomly do this, but if we times the top, so shift 8, and then square root of 2, we are allowed to do this because this won't change the value of the fraction at all. Because we could also just cancel out these root 2's and we'd just be left with what we originally had. So we're allowed to do this. Now let's simplify the top. We can get rid of the 1 and the times symbol because timesing by 1 doesn't do anything. Go ahead and change that now. Okay, use the arrow keys to get across to here. Backspace, backspace. Right. And like we said earlier, square root of 2 times square root of 2 is just 2. So replace the denominator with 2. Yeah, if you see an asterisk when we're talking about maths, that usually means times. It's just hard to type on the computer. So that just means times. All right, let me use the arrow keys here to get down to here. I think we're just, okay, we're just going to delete this entire denominator because root 2 times root 2 is 2. Okay, so as you can see, we didn't break any rules there, but now it looks a bit nicer. Awesome, let's add it to the table. So square root of 2 over 2, don't forget, don't do that. We've got to make sure we're outside of the square root and then go over 2. So use the right arrow key to get out of it. And then press enter. Perfect, now let's do cos. Type the formula for cos theta in. Okay. Cos theta equals square root of 2. Oops, got ahead of myself there. Cos theta equals adjacent over hypotenuse. I was thinking about the square root of 2 here because I'll explain now it's in the table. See how we have 1 over 2, we have square root of 2 over 2, we have square root of 3 over 2. And so by rationalizing this denominator, now it's over 2 as well, and it blends in with the rest of them. It's easier to remember. This square root of 3 here, as you'll see, it's easier to memorize it if this square root of 3 is on the bottom. All right, let's submit that. Now replace theta, a, and h in the formula. Okay, theta is 45. Adjacent is 1 because it's this length down here. It's next to the angle there. So 1. The hypotenuse is still that square root of 2. Super. You might have noticed we got the exact same result as sine 45. Okay, cos 45 is 1 over root 2. Okay. That's because for 45 degrees, it's exactly halfway to 90 degrees. So the opposite and adjacent side are always the exact same length. In this case, they're both 1. Yeah, so a 45 degree angle, you have to go across and then go up by the exact same amount. It's the only way to make a 45 degree angle. So the opposite side here is 1. The adjacent side is also 1. And the cos and sine formulas are both just opposite and adjacent sides over the hypotenuse. So they're going to be identical. That also means we can rationalize the denominator the exact same way. So just replace the 1 over root 2 with root 2 on 2. We already know this is going to be, if we rationalize the denominator, it's going to be square root of 2 on 2, just like the last one. Nice, let's add it to the table. Okay, square root of 2 on 2. Let's press enter. Awesome, now let's do tan. Type in the formula. Tan theta equals opposite over adjacent. Nice, now replace the variables theta, O, and A. Theta is 45 degrees. The opposite is 1. The adjacent is also 1. Awesome, and 1 over 1 just equals 1. Let's add it to the table. That was an easy one. Awesome stuff. Okay, only 2 more angles to go. Next one is 0 degrees. Okay. Think of 0 degrees like this. Remember that if the hypotenuse is 1, we can think of sine theta as the vertical length of the triangle and cos theta as the horizontal length. All right. Drag the line to rotate it back from 45 degrees to 0 degrees and watch what happens to the length of the opposite and adjacent sides. All right, so click and drag the line drag it down to here. And what's happening? Looks like the green line, the opposite, is getting smaller, and the pink line is getting bigger. Alright. Drag it back up to 45 degrees, then we'll do it one more time. Okay. As we go back to 0 degrees, the vertical length gets smaller until it eventually becomes 0. Drag the line back to 0 degrees one more time and watch. Okay, so if we're focusing on the vertical line here, just gets smaller and smaller and smaller until eventually it's just 0. Okay. And the horizontal length gets bigger until it becomes 1. Yeah. So this means that sine of 0 is, sine theta is the opposite side, so that would just be 0. And cos theta is the adjacent, which is 1. Exactly. Let's add them to the table. Start with sine 0 equals 0. Okay, 0. And cos is 1. Now for tan 0, remember how tan theta equals O over A? Well, as we just saw, for 0 degrees, the opposite is 0, and the adjacent is 1. Okay. So tan 0 is 0 over 1, which is just 0. Okay. 0 over 1 is just 0. So people get confused a little bit between 0 divided by 1 and 1 divided by 0. Like zeros and fractions, we know we should be a bit careful with that. The only issue is if 0 is on the bottom of the fraction. And in the next little section, like in a minute's time, we'll explain a little bit why you can't divide by 0. But basically, a 0 on the top of the fraction is completely fine. A 0 on the bottom of the fraction is where we have to be careful. Awesome. Now for the last angle, 90 degrees. 90 degrees is kind of similar to 0 degrees. Go ahead and drag the log up to 90 degrees and watch what happens to the side length. Okay. Click and drag. What's happening here? It looks like the opposite side is getting bigger, and the adjacent side, the bottom, is getting smaller. Okay. Huh. This time the horizontal length decreased until, until it was 0, and the vertical increased until it was 1. Right. Let's do it one more time so you can see it again. First, drag the log back to 0. It's good as well because we can see what happens. We go back down to 0 again. The adjacent gets bigger and the opposite gets smaller until it gets down to 0. And now back to 90 degrees, watching how the horizontal length decreases and the vertical increases. Right? Yeah, horizontal decreasing, vertical is increasing until we get a 1 and a 0. Nice, so as you can see, that's why sine 90 equals, so sine is the opposite, and now the opposite is 1. And cos 90 is, cos the adjacent, and that is now 0. Let's add them to the table. Start with sine 90 equals 1, and cos 90 equals 0. Cool. Now for tan 90. Remember tan theta equals opposite over adjacent? And we just saw the opposite is 1 and the adjacent is 0. So tan 90 equals 1 over 0. But in maths, we can't divide anything by 0. Think of it like trying to divide a pizza into 8 pieces, then trying to divide another pizza into 0 pieces. It's not possible. You can't divide a pizza into 0 pieces. And it doesn't really make any sense. So 1 over 0 and tan 90 is actually called undefined. So just type in a capital U in our table. Cool. Great job. That's all of them. In the next lesson, we'll go over a way to easily memorize this table. Even though it seems like a lot to remember, there's a way to memorize it that makes it much easier. Then we'll apply it to some practice questions so we can practice using the table. For now, let's let Mr. Frog rest. Okay, we've unlocked level 6. So, go ahead and do the practice questions now. And then, when you're finished, we can tick off this lesson and we can go to the next one.